This is House Planning Help, episode 202. Hello, I'm Ben Adam Smith, and this is the podcast for you if you're interested in self-build, because I'm exploring what houses we should be building in the 21st century and trying to break down the major roadblocks that may get in our way. Coming up, my guest is energy consultant and building services engineer Alan Clarke. It's an episode about my own project as we dig out the plans for the ventilation, heating and hot and cold water systems. Happy New Year. We're in 2018 and my goal for this year in particular is to provide you with as much insight as possible about my own project because it's on site. We'll do that in the podcast, we'll do that in the hub, perhaps on social media, maybe if I meet you out and about at an event somewhere. If there are any questions, any gaps along the way, I want you to stop me and let me know what they are, because it's all too easy when you're making a podcast to just pick out perhaps the juicy bits or the bits that I think we're learning something here when in actual fact, sometimes maybe we're learning elsewhere. So if you see that happening, get in touch. For the quickest response, probably Twitter is easiest, at Ben Adam Smith. Follow me there. Right, let's jump to it. Our chat with Alan Clarke. This is his second time on the podcast. Last time around, we looked at whether you can dispense with a heating system in a passive house. Just going to pause there, stroke my chin for a moment. Houseplanninghelp.com/62 if you haven't listened to that one. Wow, that was a while ago, wasn't it? Today, I'm hoping to discover how he came up with the plans for the ventilation, heating and hot and cold water systems, because we didn't have to do much really other than look and think, Alan, yeah, very interesting. We told him a little bit about how the rooms would be used, and I think that's pretty much it. So let's get into this conversation. I started by asking Alan what his role entails.
If you think that's an easy question to start with, I don't think it is. I've got one easy role, which is the building services designer, which is a fairly straightforward engineering role of producing designs for the heating, plumbing and ventilation, possibly for the electrical layouts as well, depending on whether the architect covers that or not. And then also some energy analysis role, particularly for passive house. Some of the boundaries tend to split with different design teams. So some architects' practices keep the energy analysis in-house, which makes sense if they're energy literate and using PHPP, because the first stage of PHPP is working with the building fabric, the windows, the form of the building and the insulation and so on. So that is a fairly architectural side of the design. Though I still do that with other architects who aren't particularly interested in getting into the spreadsheet side of things.
So at that point when we've hired you, what are the first things that you want to do to be able to begin your work?
Probably the first things, practically speaking, are making physical space for the particular services we want in the passive house and to make them work well. And that is the ventilation side, is what's people aren't normally familiar with. Obviously, architects like Parsons and Whitley are experienced and familiar with what they're doing.
Take us through then some of the things that you're doing, what programs you're using to come up with all these drawings, and how you're specifying the MVHR. Give us some detail. All
right then, for a passive house, which has got a main business here, I actually work from the PHPP energy analysis program, or within it quite a bit to start with, because there's a sort of interplay between the services I design and the useful information about the building that's in the PHPP. So I would start developing the ventilation scheme in terms of the numbers, the airflow to each room, how that all balances out. That's got to work on the plan, so you can see which room is a supply type of room, which is the bedrooms and living spaces, and which rooms need extract from them. So you look at that on the plan, identify those, maybe identify if any, for instance, a toilet off a cloakroom or something, and there might be no need to extract air from both of them, and then schedule that out in the ventilation worksheet that we use for passive house, and feed that back into the PHPP so that we, from an early stage, modelling with the airflow system that we expect to design to. The other thing I sort of start to pull out from the PHPP is the heat loss information. For instance, all the window areas and the U values of the fabric and the windows. And then when we come to looking at the heating system designed in more detail, I can use that information to work out the heat loads for each room.
So if I understand this correctly, first of all, it's very much about ducting, looking at PHPP to see that what you're about to specify is going to be right, but the heating comes further down the line, what physical equipment you're going to have. Does that come before the MVHR unit, or do you work with the same MVHR units?
Okay, sticking with the ventilation. I think the ventilation is probably...
We stay with that first.
Bit more important to get right in. Well, it's a bit less swappable. It's got to be there from the start. I work with a few different ventilation systems, all Passive House certified and all easy to get hold of in this country. But the certification for the Passive House MVHRs, first of all, tests the efficiency under the sort of methodology that fits in with the energy calculation in PHPP. Also, typically with the Passive House approach, it's not an optimistic methodology. It really looks at how much heat your MVHR is losing out of the house, and other ways of looking at the efficiency tend to attribute heat loss from the room where the MVHR is into the system as being a gain to the heat supply to the room that the air's supplying to. These are quite subtle differences, but in order to encourage you to use the certified units, the PHPP, the Passive House certification, docks several percentage points from any sort of claimed efficiencies from a non-certified unit. So it's, in the grand scheme of things, cost effective to use a certified unit. It also ensures we've got things that you need in a Passive House, which is frost protection for the MVHR, which means when the air is sub-zero, the system won't shut down the supply air, which is what some non-Passive House certified systems do, which doesn't really make sense in an airtight house where you need it for your ventilation. So that's one of the things about that. And the other thing is that they've always got the sort of commissioning controls to let you set them up in a properly balanced way, so that we're not wasting heat through unbalanced supply and extract, where if, say, you supply too much air, some of it is actually leaking out through windows and cracks and so on. So it's the commissioning side of the MVHR is important, but you need a piece of equipment that is designed to be commissioned properly.
And that's not part of the process you do, the commissioning. You just give the equipment that you know can be commissioned, correct?
Yes, that's right. I mean, I have commissioned a few units. For instance, in my own house, of course, I'd have to do everything myself. And
what did you learn through that process? What does it mean in practice when you're commissioning something?
That it's quite hard to measure airflow accurately. Also, you pick up on the fact that it could be quite hard to get a high airflow rate at a distant terminal, one that's furthest away from the ventilation unit.
And I noticed that on a lot of the duct runs that you have in our sketch, that they almost just get into the room when it's furthest away from the MVHR, if this all makes sense, that are you trying to keep those runs short?
I'm trying to remember exactly what it is like, but sometimes...
Is this time to dig out? We can put this into the show notes too, but do you want to have a quick look at it? Let's do this.
Okay then, yeah.
Okay, so what I've got in front of me, which, as I mentioned, we will give you a chance to look at in the show notes, is the floor plan, and you just overlay your designs over the top. Is that pretty much how it's happening?
Yes, I'm not fully BIM stage anything here, I'm afraid. Most of the architects working with on individual houses are generally doing their working drawings as two-dimensional CAD drawings. I take their drawings and hide all the various notes that aren't particularly relevant and just do my own drawing overlaid on top of that, so that we should see that everything matches up physically in the building.
It actually seems to be the upstairs where there's not much ducting, the downstairs. Yes.
I mean, there's, maybe if you sort of wind back a little bit, there's two philosophies of where to go, and we're the purists in terms of airflow. The other way is to think, there's hardly any ceiling space. If we just make the ducts really flat, like 50 millimetres, we can squeeze them in and no one will know. The downside is there that you need more fan pressure to push the air through these smaller ducts, and more fan power means more energy in the fan. It means more noise generated at the unit. It means more electricity consumed in the fan, and also that tends to be a system which doesn't come with well-sealed junctions in the ductwork. So we've got a other approach which has always borne fruit in terms of quiet and efficient systems, which is to use slightly bigger ducts, round ducts, which are inherently easier to make airtight junctions, and then just try and think a bit more cleverly about how to make space for them. And this is kind of evolved from over the years, with some feedback from the builders that we've worked on as well, on what's a good way to go. So you see the ducts are spread around quite happily on the lower floor, because we're using open web floor joists, which are engineered to joist with a sort of metal zigzag, which gives plenty of space to fit services through. So that gives us plenty of scope there. But upstairs, if we look at the upstairs, you probably found that a truss rafter roof is a sensible and economic way to make a roof. But in a passive house, we make that the air barrier is the base of the trusses. Loads of insulation goes on top, and there's no way I want to be putting lots of ducts up through that air barrier and into that cold loft space. We want to keep them inside the warm airtight envelope. But it means we're going to have to drop the ceiling somewhere to run those ducts. So we're using the simple philosophy that the landing tends to connect all the rooms together. So we'll run the ducts in the landing, and it doesn't have any windows, so you won't lose any window head height if we lower the ceiling a bit, and you won't really mind having a lower ceiling there. And then that's why the ducts stop at the bedrooms, because they'll step up to a higher ceiling. And we use a side throw air terminal that's designed to be mounted on a wall and designed to sort of jet the air into the room so it mixes up.
So it doesn't need to be in the middle of the room. You see, the novice that I am, knowing nothing about it, I'd say, does that not need to go into the middle? But I trust you. It's all right, Alan.
It's okay. It's not just the novices. It's sort of, and it's not intuitive, I don't think. So being the geek wing of this sort of thing, we have had the CO2 monitor set up for consecutive nights in our bedroom, which has MVHR vent supply just over the door, trying to see if there's a discernible difference in the carbon dioxide concentrations around the room with such an asymmetric air supply, and really didn't find any. Then it's not actually just down to the air terminal throwing the air physically across the room. It's just the air does circulate in rooms quite well.
Oh, interesting. Okay. And the ducting system, I remember from one of our early podcasts, and probably have got the details wrong, but I think it might have been Andrew Farr suggesting a rigid system. Will this be rigid, or have we moved on from there now?
We're using rigid here, yes.
I think the ones that I've seen from Green Building Store that I know we're using have all been metal as well. Is there an advantage to that? Or
I think there are some advantages, yes. Some of it isn't inherent to the metal, but it happens to come as a very well engineered system with smooth bends, so it becomes a low pressure loss system, and it comes with sealed junctions with little rubber gaskets, so you can build a ductwork system that doesn't leak without having to lash lots of sealant or sticky tape all over it.
The particular unit that we've selected, what is it, and why have you chosen it for this project?
It's a relatively new Zender Passive House certified MVHR, fairly large capacity, so it's suited to family houses, and it's been designed with integral sort of airflow measuring inside the unit, which means that you can set it up and choose your ventilation rate, say it's 150 metres cubed per hour, dial that in the controls, and it will maintain that even as filters get dirty or other conditions impose themselves on the system. So it makes it, in that sense, quite easy to set up, and it also means that you won't start losing ventilation performance as time goes on, as you don't get around to changing the filters and they quietly sort of increase their resistance. I mean, that's one of the issues maybe with a low resistance efficient duct system, that a blocked filter will make quite a difference, but I think that's probably the case with most ventilation systems, to be honest.
Are we using any sound attenuation? Is that the right terminology? Or is it just not necessary because this machine's so quiet?
No, we are using sound attenuation because it's got this flow measuring. The fans don't have to have any integral consistency in flow rate. The speed can be adjusted in response to the measurement. So the fans have been designed from the ground up to be efficient and quiet, but we're still basically designing to the passive house acoustic requirements, which is 25 dBA in bedrooms and the living room. And for that we need some attenuation in the ductwork, which is a cylindrical silencer, which is a straight through tube with an absorbent material round the outside with a perforated baffle. So that doesn't impose any air resistance, but is quite good at taking out a lot of the noise.
One of the issues that we had on this project, I think it probably comes back to your terrible clients that you had, was the fact that we changed the size of our kitchen and reduced our utility area, which meant that the MVHR system did not have enough room. And then we looked at a possibility of having it upstairs, and eventually we settled for it being outside the thermal envelope. So you didn't seem too fazed by that. I know that Chris and the team were certainly just everything they do, they like inside the thermal envelope. So can you explain a little bit of why you suggested this and some of the issues that perhaps we were worried about that maybe we shouldn't be worried about?
Okay, it's not outside, it is in the garage, so it is in a protected space. And I think we should be pretty unlikely to be sub-zero in the garage, and the duct heat loss side of it is catered by having insulated ducts from the MVHR to within the house, and by putting the unit just inside the garage on the wall of the house, those ducts are very short, so the heat loss from there is pretty small. Interestingly, the sort of average temperature inside the MVHR unit, when you think of it as a mix of outside air and inside air in the same unit, that the average temperature inside the box is halfway between outside and inside, so it's not obvious that it belongs inside or outside. So it's not an extra heat loss from the MVHR to put it in the garage. It might even be slightly more efficient, basically. As an aside, there's an interesting project of trying to build the MVHR actually within the wall itself, which is the sort of ultimately logical place to put it, so that it's half inside, half outside itself. But it's got some practical problems of dealing with condensate and connecting ductwork not into the living space. But that's...
Will the MVHR unit be in a protected box, or is it just going to be there in the garage? It's obviously, as I think you might have mentioned just before, the ducting all goes to the outside as well, for the fresh air.
Yeah.
Because I remember my wife was just saying, but why don't you just get all the fumes from the cars?
Oh yeah, so we're certainly running intake and exhaust ducts out through the garage wall to outside, yes. It's up to you whether you put a box around it, to be honest.
I don't know. I follow your lead, Alan. I don't question you.
It's not a problem. It doesn't need it. Yeah,
it won't be in a box then in that case. Look at a couple of other aspects then, the boiler system. And did I imagine this in the early days? Did you suggest underfloor heating for us? And if so, why? Because I thought underfloor heating was the devil.
I don't know about the devil, and I think it must have been your project architect, actually. Dan, I suspect, because it wasn't me.
Okay, right. But why do you steer clear of underfloor heating?
Sort of issues we've got are that it's inherently quite a high output system, as it's got the whole floor available to heat the space, and also means it's expensive. You've gone and cut your heating demand down by a factor of 10 in a passive house, but you still got to pay the full rate because you're still covering the whole floor with underfloor heating, which doesn't make a lot of sense to me. And then you've got something that's too powerful, so you have to then put more effort into the controls and the design to try and throttle it back to a point where it will work.
So will we be using our heating system a lot of the time, just very low settings?
I think my experience of detached houses, that's probably right, yes. And obviously, as you were discussing earlier, because of the size of the plot, you're effectively encouraged to build a fairly decent-sized house, so that you're not got the same sort of occupant density as the social housing projects I work with, Parsons and Whitley, where they would have at least 2 4 or 5 bedroom houses with the same floor area, so it would be more people, more internal gains. So yeah, I expect you'll be using the heating a bit.
And tell us about the boiler, the Valiant Ecotech Plus 615.
It's actually very ordinary, is
Yep.
part of the point, basically, is that...
Yeah, it's gas as well, isn't it? I suppose that's something we should talk about, because you did ask me, would you have just gone if I'd said I wanted a ground source heat pump? But again, this is the podcast things washing over me. I'm sure if you have access to gas, you always suggest, or not necessarily you, but someone has told me in the past to use it.
Seeing more projects with air source heat pumps, generally off the gas grid. I mean, in the past we've done them with LPG, but I think it's becoming more common to go to air source heat pumps. Although there's higher capital costs, they've got lower running costs.
But what happens when they break? Because I've had this question from people before who've said, Ben, I'm having this taken out because there's just no one to fix it. Whereas if we had a normal gas boiler, there are thousands of people who know how to fix it.
Yeah, I mean, that's why we're using a mainstream brand. I mean, there's some people who've thought, Passive House will have to find the gas boiler that has the lowest possible output. It's a special import from Germany. But then, as you say, if something goes wrong, your plumber from Berkhamsted isn't necessarily going to know what to do with it. But if you've got one that's one of the mainstream ones with spares and technical support, that's all going to make your life easier. So, the heat pump market was a very, what's the word, not quite bespoke, but quite individual supplier business. Now seeing quite a few housing associations working with, for instance, Mitsubishi, and there are other manufacturers as well who've got quite a bit more support in the country than they used to. So that's probably where we'd go otherwise, yeah.
Now, I know that we've jumped about a fair bit, and I probably haven't done your processes any favours. Are there any other key parts that we should mention in what you do?
In terms of the house design...
and this particular case study?
Looking at hot water distribution, which is something we've done research on and have as ever, a slightly individual approach to, which is aimed at getting hot water to your taps nice and quickly, but without any circulating hot water that's continually losing heat into the rest of the house. So we do that with smaller bore pipework, which has become possible with mains pressure, unvented hot water systems. So there's a little bit of a design exercise in looking at the plan of the house, drawing on where the pipes have to go, seeing how long they are, and as ever I've got a spreadsheet now tacked into the PHPP where I check the pipe sizes are going to match up with the flow rates and the available pressure, and then that all sums up the numbers to pop into the distribution in hot water sheet in the PHPP to work out the heat loss as well.
I know you recommended a flow restriction as well, which I'm all happy for. However, there's one concern, which is if my wife turns on her shower and says, I knew we shouldn't have had this on day one. So it's very difficult to gauge what that means and whether we need it or not. Can you isolate it and just say, well, her shower, let's just make that go a bit faster?
Sure, we can design for a higher flow rate shower if you want. I mean, it is possible to have a low flow rate that's a bit disappointing, to be honest. Yeah, but I think there's some diminishing returns as you go for more and more water. The extra pleasure and enjoyment becomes less and less.
So where's that sweet spot?
I think it's probably around. But maybe I'm being very stingy if I say about 10 litres per minute, and someone else will say it's more than that. But I think that
I'm going to hope that she just doesn't notice. We'll continue on as normal. I'll say, it's too difficult to retrofit. It's too difficult.
I don't know what your showers are like at the moment. That would be useful to know.
Well, no, I mean, you've no worries there. Our showers have been dribbles all of our time, so hopefully it will seem like a big improvement. And does the actual equipment, this is actually something we're specifying at the moment, the bathrooms, should we be trying to make the shower head something in particular to maximise what you've done?
Yes, I think so, in that a lot of manufacturers have a range that is designed to work with some level of flow restriction. I mean, so some of them might have some handsets that are designed for 6 litres per minute as a very eco low water use, but they also have recognised that there's people who want a bit more luxury and go up to sort of 12 litres per minute, but they're still fixed at that, so they're not going to run their hot water tank empty and going to still be relatively energy efficient and water efficient. There's quite a few options, but it's still better to have something designed like that rather than a shower head that maybe is expecting twice as much water and then you put a little restrictor in it upstream and it'd be quite disappointing. You've got to have a shower head that's designed to work in conjunction with some sort of flow regulation.
As we get towards a close, a couple of things that are still in my mind. One of them about, I suppose I was surprised that there was a radiator in each room, and this may come back to what we were saying earlier about this is not necessarily a small house anymore, and just keeping that even temperature with a low amount of heat in each room.
I mean, by some people's standards, there isn't actually a radiator in each room. I can't remember exactly, but I think we put in fewer than might be standard.
Oh yes, yeah, definitely.
Yeah.
I'm just saying one. I mean, this is probably a tiny radiator as well.
But for instance, I remember you've got at one end of the house, you've got a bedroom which has effectively got 3 external walls, balcony doors perhaps, and I've got some clients who actually sleep with the windows open in their passive house and have no heating, and obviously they are very happy with that because that's what they wanted to do, and it's great. And then other people actually want to have their room warmer, particularly when we looked at, for instance, the room at the other end, which is a bedroom, but I happen to know is a study or a workroom as well. And it's one thing to snuggle under a duvet at 18 degrees in the cold weather, and it's what the British standard says to design a bedroom to 18 degrees, and I can do the calculations and say we don't really need to put a radiator in there. But if you turn it into an office, that's going to be a bit chilly for the typing, and you want 20 degrees, so we put a radiator in there. Again, if you've got a room downstairs that is for elderly parents, I don't know what they'll want, but you might as well be able to keep it warm if you need to.
Good thinking, like it. When you get to the end of this process, we've hired you as a consultant. What is the final documentation that you're passing back for the tender process or the next stage of the project?
Okay, so what I'm doing for this type of project, which is quite a small scale project compared to what a lot of engineers do, is not handing over a 500-page standard specification, but instead writing something fairly easy to follow and as short as possible to, on the one hand, provide a shopping list for the contractor to work out what he's got a price for, and also provide basic instructions on particular things we want to be installed in particular ways, the pipe size, the thickness of insulation, and a list of the types of terminals for the ventilation unit itself. So all the kit has got to go in there, plus the instructions on how to get it commissioned and what flow rates to commission the ventilation system to. So I try and keep that into a shorter specification as possible.
And finally, are we likely to be needing you again in this process? Do you come back at the end, or is that fairly much you've been the consultant, job done?
It varies depending on the builders, to be honest. So I don't know. I haven't been introduced to your contractor. I've quite often have a small amount of involvement, particularly if they're not used to what we're doing in particular ways, and talking through that. Sometimes it involves going to site, particularly on the sort of seeing how things fit together at the first fix, and maybe again towards the end. I mean, obviously as a client, you can see it'll be expensive to ship me over to your house for a monthly site meeting, so I'm not planning to do that. And you're working with Parsons and Whitley, who we've worked with before, and they know what's going on, so I don't think that's going to be such an issue.
Well, Alan, don't worry. I'm sure we'll catch up again at some point.
Yeah. Okay, nice to talk to you.
Thank you, Alan. Cheers.
Bye.
Head online to take a look at the show notes that accompany this session. houseplanninghelp.com/202. You can review the main information once again because we've provided a summary. Also take a look at the floor plan with the ventilation layout superimposed. Have a look where the radiator locations are going. Oh, I did my geeky voice there for a second. Also, what else goes into the specification. We'll link you to Alan so that you know where you can find him. houseplanninghelp.com/202. Now, I was chatting to one of our new hub members and asking the question, so, Beth, why did you sign up? I didn't. Uh-oh, what's going wrong with the hub? The technology, has it collapsed on us? No, what had happened was Beth's brother had given her a wonderful Christmas present of hub membership. I like it. Thank you very much, Beth's brother. And Beth is also the perfect person to be signing up just because she's starting out on her journey, keen to learn, and is just getting stuck in with all of the online tools that we provide in the hub. That's the idea, that we're trying to smooth out the bumps in the road, simplify your self-build journey. We've got the in-depth video case studies, so we've been on site at Buckinghamshire Passive House, at Long Barrow, and we're currently filming on my own project. Then we've got the courses, which focus on particular topics and try to lead a path through for you. The progress calls, this is a monthly community call where we get together. Sometimes we just discuss our projects. Other times we have a guest who we can ask questions and just probe for information. And then we have the community forum. This is quite important. One of the main aspects is the progress log, and I'll just pick out one hub member, David Reed. He's doing such a good job with his progress log, in that I can see he hits a challenge, boom, he's just gone straight through with it as well, and he's provided a few pictures so that we know what's going on. Thank you, David. I think you're doing a grand job, and I imagine you're going to get building very, very soon now. houseplanninghelp.com/join if you want to get some more information. Next time, self-builder, craftsman, blogger, Will Anderson is my guest. Now, he managed to build his own home in central London, Treehouse, and then a few years later, he built next door, the Orchard, making it a semi-detached house that could one day become a terraced house. There's so much we can talk about in this. I think you're going to like it as well. He's an interesting character. I said craftsman for a reason. So that next time, the House Planning Help podcast is produced by Regen Media, content that matters.